Next, we'll look at some additional curation steps that you might encounter. This case, we'll be looking at a CyTOF dataset that has not been thresh transformed, so we'll have an opportunity to do that. We'll also see what happens when there are missing files indicated in the metadata. So if metadata doesn't have a particular file, so here we have 6 files, and on the other side we are missing a file that's conveniently named missing file. And also we have an md5.local file that appears in the metadata, but this is not an FCS file. So this is just to handle a few edge cases that you might encounter. And again, we should specify our reference, our samples to register, and our samples to shift. So for the reference, we'll use just this first sample. For the samples to register, we can do this one, and skip that to this one, and then samples to shift. For samples to shift, we'll use everything except for the MD5. And we'll save that, and close it, and then we'll go back to our registration program, load our new metadata file. Okay, it's asking us to move on to the registration settings. And again, we are going to speed things up by doing a smaller concatenate. We will continue with the batch registration. We'll do NDCR only. That'll speed it up a little bit more. Switch to file names. We'll put in our reference, our samples to register, our batch IDs, and our samples to shift. And now when we validate, it's going to have some problems with the data. So it says the first thing is the missing file is missing. Continue with the missing sample? Yes, that's fine. Next thing is it finds an md5.local and it asks if we want to continue with only valid FCS files, and that's fine. And now it sees that there are some discrepancies with the channel names. So we'll go ahead with that and modify the channel names. This is a CyTOF dataset, so there are lots of channel names. The trick is finding the ones that are different. It looks like everything is fairly consistent except for this last one here. So I will just include all of them for now. And set output labels. And we'll create new file names, new channels. It's going to append MDC for modified channel names. And it tells us that it's created a new column in our metadata file. And now we can do the threshold transforms because this is CyTOF data. So again, with the threshold transforms, the instructions for what each of these pieces mean can be found in the help menu on the right. But to keep things simple, we see already that there's the list of channels on the left. There's an option here to omit certain channels. And then we have our threshold value and our noise value. What the threshold value does is any value below this number is treated as, is changed to this number. And then the noise value is a log normally distributed random jitter that is added to each event in every channel. And 3s are generally what we go with as the defaults, and it tends to work well for most cases. So that's the recommendation for doing the threshold transforms for CyTOF data. You can experiment with different values, of course, because this will give you the option to create new threshold transform files, which you can then inspect in your favorite flow cytometry visualization program. And also, since it added this extra channel, I'm going to opt to omit that one because I know in advance that some of the files don't have that channel, so it's not going to be consistent across all of them. And so it's, for this particular purpose, it's safe to drop. And it's telling us it's going to create new files, so we'll allow it to do that. And we can see them appearing right now. They have the underscore thresh appended to the file name before the FCS, and it tells us that it added a new column to our metadata file, as we would expect. And it's carrying on with the validation. It concatenates the reference sample, and then we can proceed with the cluster settings. For these new files, it has omitted the 29th channel, and everything else looks good. Again, for CyTOF, the arcsine scaling factors are generally set to 1, and for the cell length, that's similar to a scatter channel in a sense, so we treat that as linear. We can take a look at these, the effects of these transformations, and once we're satisfied, we can close that window. And again, these all look good. And we'll proceed with the validating channel data. And I'm going to drop the number of clusters a bit because I have an idea about the complexity of this data set, and I'll begin registration. Very simple. We're going to use this one sample as our reference. We've defined 2 batches. One batch has 2 samples, another batch has a single sample. For the batches that have multiple samples, they will be aggregated, and for the single sample, it will be just treated as a single sample. And then the batch shift templates that result from each of those will be applied to individual samples to bring them into alignment with the reference. And I'm happy with that, so I'll accept the process. And then I'll fast forward. And again, batch registration completed successfully. So we can close this and this. And we'll see our original files listed down below. Each of them has had their channel names modified, followed by thresh transforms. So you'll see MDC thresh in each of the file names before registration. And then after registration, we again have the underscore RGST appearing in the file names, and the file names themselves capture a bit of the history of what was done to them. As always, there should be a log file that describes the process as well. And that is registration with CyTOF data, in which there were a few extra error checking steps in the beginning during the validation, as well as the application of the threshold transform to the CyTOF data.